In this video, we will discuss how to design ladder diagram for timers. Application of timers, we will design the ladder diagram. So before going into the design of the ladder diagram, so we'll discuss about the timers first. Timers are built-in devices in a PLC. Timers count fractions of seconds or seconds using the internal CPU clock. Timers, when energized, result in the closure or opening of the contacts after some preset time. So the timer is thus treated as an output for a rung with control being exercised over pairs of contacts. So timer acts as a delay block which when inserted in a rung delays signals in that rung reaching the out. The time duration for which a timer has been set is termed the preset time and is set in multiples of the time base used. Some time bases are typically 10 milliseconds, 100 milliseconds, 1 second, 10 second and 100 second. Thus, a preset value of 5 with a time base of 100 milliseconds is a time of 500 milliseconds. So now we'll see what are the types of timers. So there are many kinds of timers used in PLCs by different manufacturers. So there are three predominant timers used. So first one is on delay timers. So these are timers which come on after a particular time delay. Then second one is off delay timers. These are on for a fixed period of time before turning off. And third category is pulse timers. This timer switches on or off for a fixed period of time. So let us discuss about the timer sequencing. So timer sequencing repeats a set of processes in a certain order until no additional input signals are registered. PLC sequencing is widely used in industrial automation scenarios, specifically in batch operations. The same set of processes is repeated in the same sequence for each new batch. So we'll develop PLC ladder diagram and timing diagram for the following logic. There are three mixing devices A, B, C. After the process begin, mixer A is to start after 7 seconds elapse. Next, mixer B is to start 3.6 seconds after A. Next, mixer C is to start 5 seconds after B. All of them remain on until a master enable switch is turned off. For this particular problem, we are designing the PLC ladder diagram. There are three mixers, mixer A, mixer B and mixer C. Mixer underscore A is the variable used in PLC ladder diagram and mixer underscore B is the variable used in ladder diagram, and for mixer C it is mixer underscore C. So let's denote start as a start underscore PB, that is push button, stop PB, that is stop underscore PB. So for stop underscore PB is nothing but the master enable switch. The overall system turns off after pressing this button, that is stop button. So let's go ahead to CoDeSys to design the ladder diagram for this particular problem. Before going into the design, we have to know about the timing diagrams. Let's see. So this is the timing diagram for this particular problem, that is mixer A, mixer B and mixer C. So see here, first for start button, after activating the start button, the system starts, and as you can see here, after a duration of 7 seconds, mixer A is started here. Okay, you can see the rising edge here, that is blue line. And for mixer B, it has to start after 3.6 seconds after mixer A. That means 7 plus 3.6 seconds. That means 10.6 seconds. So that is mixer B starts from 10.6 seconds. As you can see indicated here, the rising edge of mixer B is started at 10.6 and it proceeds. Next, mixer C is to start after 5 seconds, mixer B started. Okay, so that means 7 seconds plus 3.6 seconds plus 5 seconds. That means after 15.6 seconds, mixer C is started here. As you can see, it is indicated a green line of signal, that is it is starting at the rising edge and it is proceeding. So now after the falling edge of all these three mixers, the stop button is going at the rising edge. So that is when you press the stop button, all the mixers A, mixer B and mixer C will stop and the system stops working. So in this way, the timing diagram can be drawn like this for this particular problem. So let's see. Go to file, new. So first rung we'll design it for mixer A, and second rung is for mixer B, and third rung is for mixer C. So first take contact here, write the name of this as start underscore PB. Give the parallel contact, that is for output n underscore 1 RL, that is for using edge. So we need to take master enable switch as stop underscore PB, take a negated contact, that is negated contact acts as a normally closed contact, stop underscore PB. So we need to take timer for mixer A, that is we have to take timer T on timer. Click here, you can see here timer T on here. So name this as TON underscore 1. Hash, that is for mixer A, that is 7 seconds. You should use this as a time variable, time type. Click OK. Take a coil, name this as mixer underscore A. Okay, first rung is for mixer A, that is over, and second rung it is for mixer B. Click here, take contact, do the timer sequencing by giving the value of output of first rung as the input of the second rung. So we need to take timer for mixer B, that is for T on. Name this as TON underscore 2. Time is for T hash 3.6 seconds. Name this as B. Fuse time. Give the coil output mixer B. So next rung is for mixer C. Again do the timer sequencing. Give the T on timer for mixer C, TON underscore 3. T hash, this is for 5 seconds. C. Use this as time. Click OK. Give the coil output. So save the file. So now it is saved the file. Now we can run the design. So before running the design, we have to build the design. Click on project, click on build. You can see there are no errors and no warnings. Let's go ahead. Go to online. Keep this in simulation mode. Click on login. Activate the first push button, that is start push button. Write values, run. So you can see after 7 seconds mixer A is starting. See, you can see mixer A is started. After 3.6 seconds, mixer B is started. After 5 seconds, mixer C is started. So all these three mixers are on. That means they are remaining on until the stop underscore PB push button is not turned off. Okay, so let's turn off this switch. Right values. So you can see all the three mixers turned off. So this completes the ladder design for this particular problem, that is for three mixer devices, mixer A, mixer B, mixer C. Thank you.